following session, entitled Teaching Math Classically, Using Tools in the Trivium to Support K-12 Mathematics Education, will be presented by Cheryl Jordan, who has over 30 years of experience in mathematics education, both as a teacher and leader. Please welcome Ms.
I'm honored to be here with you guys. It's been a delight this week for me to be here. My first time ever. I last summer decided to Google teaching math classically, and that's how it all started. And ended up in taking the Classical U course for a very intense week. And that gave me an overview, but it reminded me once again, wow, you've done a few things. You have a few things you could share with others. And so I dug deep for the year. I decided to get my CCLE certification, which I'm still need to finish it up. So if Jackie Gates is around here, I'm a little behind on what my original plan was. But
you can do it.
Yes. But my intent today is to kind of give you an overview of what I found, because I think as a true practitioner, which is what you guys are, you're out there with your students. You don't have a lot of extra time to know what has gone before and what is currently going on. And so I'm sure there are things that I'm going to talk to you about that have already been presented. But again, it's a snapshot of a lot of things, and I'm hoping that it's kind of an ongoing conversation that we can have from year to year. So let's just call this part one. That's kind of my intention here. So, and I toyed with the idea of, I'm going to do the PowerPoint because we sang so much and my voice was not going to last. And I thought, well, then at least they can read it, right? But then I'm shying away from that now. Would like to speak more organically and more off the cuff, and would like to feel out my audience a bit better, because I think that's always good teaching. So I've done a lot of things. I'd like to figure out what you guys are doing at the moment. So I'm just going to ask for a show of hands here so that I get to know who you guys are. I'm assuming we're all teachers in different capacities, but some might be administrators. So I guess if you're more of an administrative type, I would love to see a show of hands on that, okay? So you might be people who can spearhead curriculum choices, that sort of thing. The rest of us are teachers. I'm curious how many are homeschoolers, if there's any homeschoolers out there. So I've landed in homeschooling, coming from all different places in life. And I realized as I was trying to prepare for this, that I really come from kind of the full dichotomy of everything. And so I can relate in so many ways. And again, I see this as the beginning of a conversation. And so I've gone from, teaching subjects to teaching strands. I participated in Classical Conversations as a director for a bit, and that was very formative. And actually, that's kind of what sparked a lot of things in my life. Also did research very early on, and also I'm a practitioner, right, in many ways. I've been a tutor of one, and I've been a classroom instructor of 40 plus at the university level, so that's been interesting. Homeschool, I actually helped establish a parochial, a Lutheran, El Samus Lutheran private school, obviously, and I've taught public school, so I can speak to all of those things too. Lead learner as a participant in Classical Conversations, and a master person, master teacher now. I would get so bored of teaching algebra that doing it at the college level, I would glance quickly at the examples and be like, okay, I'm ready for class, because I love the spontaneity, and so I feel like there's a few things that I've learned there with all the years. And classical and modern, I've toyed with both of those things. Teacher, administrator, and then the full gamut of all the different levels, having dealt with my own children and also having taught math for elementary teachers. So I've done all the things, I feel like, in a way, and but I'm still learning. We're all still learning on that. And I think what does classical do well? It encourages all of us to be lifelong learners. So I think that's part of why we're all here. I want to just start with a little, I'm just going to call it a prayer here, in a way. Johannes Kepler, it's a little wordy, but I guess, and maybe I won't read the exact prayer, but the premise of the prayer is basically, I hope that what I share with you today does not hinder you in any way, that it actually lights you and that it gives glory to God, I guess, and that it actually acknowledges that He is the maker of all things, and that through mathematics we can see His hand through creation and all of those things. And so I guess we start with that. And so my overview today really is giving just a snippet of kind of the formation of the quadrivium versus the trivium. I think it's good to know those things. Also, to compare kind of truly classical mathematics to what I would call kind of neoclassical. So some of us say we come from classical schools, but then how are we actually really implementing that? And also how the skills of memory, inquiry, and writing, presenting, kind of how those fit in. And I guess I missed the punchline on this. I blanked for a moment. In all of these things that I've done, what was really interesting and ironic is that everything pointed to a lot of these things here, which I would call the trivium. And so, doing the research, having the experiences, either tutoring, teaching, or whatever it was, so many of these things kind of focused here for me. And I being a pattern person, as a math person, right, I could see like, wow, modern tells me to do this, but it all pointed to the same thing ultimately. And so it was really fun for me as I was watching that class last summer going, oh wow, it all points to this. So just a little background there. The ancient cosmology or worldview, as many of you might know, really kind of pointed people to what we would call analogia, I hope I'm saying that correctly, and taxis, which is basically the idea of realizing that the world is ordered and that the ideas of proportion are really important in how it forms our mind and how we see the Lord there. I thought this was interesting. Even drawing a triangle, they believed, was a way of participating with God who makes perfect triangles. And so I think that's kind of a fun way to think of that. And they believed very much so in the quadrivium of arithmetic, geometry, music, and astronomy. So we've all kind of seen that. And again, in our math programs, are we able to dabble in those things? That's always a question. But we know ultimately, right, the unchanging truth of math allowed those ancient philosophers to understand the universe through the natural laws that govern the physical world. And so the arts, right, I just mentioned those. I found, as I was kind of Googling things and looking around, I found a really interesting diagram, and I thought, wow, sometimes a single image, as we all know, can mean a lot in terms of how it changes your thinking. And this particular one really did that for me. And it was originally drawn with the triangle in this sort of formation. And, so you had it more like this. And with the quadrivium on this side and the trivium on this side. And I thought, for those of us who are math people, right, we see a 3, 4, 5, right, triangle. It's kind of a cool way to think of it. But, and I think Jackie Veith actually, in one of the articles that I've read of hers, she talks about the trivium supporting the quadrivium. And so I thought, well, let's just do it this way, right? So I think it's interesting to think about how the trivium, which many of us can think of as the grammar, dialectic, and rhetoric that we're instilling in our children, right, as teachers, that the trivium really supports the quadrivium. And so I would put that on the bottom of the triangle and have that side of length 3 maybe supporting all the rest. And so I thought that was interesting. The 5 caught my eye because I'd never really considered that before. But it makes sense. We do have 5 senses. And what a kind of beautiful way of integrating in our minds the 3, the 4, and the 5. And so I found that and thought, wow, I need to make sure that's really kind of a focal thing, because I do truly believe the trivium can help support our math. And I think we probably all implement many of those things in our classes. In some cases unknowingly, but hopefully we can do it more intentionally and get some new ideas. And so the quadrivium, it really began, I would say, and again, some of you guys might know the history better. This is a very superficial kind of summary here, but it originated, I would say, with Pythagoras in 500 BC. You've probably heard of the Pythagorean theorem, right? So he was part of a group of people that loved to think about these things, ponder these things, and he sought to find the eternal laws of the universe, right, in mathematics. And it was organized, and I hope I'm saying his name correctly here, Boethius, Am I saying that right? I don't know. In the 6th century. And for almost a millennia, he had organized it. I guess I should back up just a little bit. He had organized it and formalized the quadrivium to include, he translated Euclid and likewise Ptolemy on astronomy, and wrote text on arithmetic and music. And so he kind of formalized things a bit more. I don't believe we have a lot from him. I don't know, maybe you guys can speak to that, but I don't think we have a lot. And so unfortunately, we really don't have like the canon of things as we should. We have some things, but I don't think we have the full scope of what we need to truly have a classical math program. And we would say also too that the quadrivium was very focused on integration, right? So that's kind of definitely something that we're all probably aware of here. So then the English Renaissance comes up in 1600s. And so there's kind of this renaissance, there's kind of this revival of classical thinking. But for good or bad, it focuses mainly on these things here, the trivium, right? And so those things are really emphasized. And so for a long time, that becomes, and Dorothy Sayers, I think, was very much part of that, right? So she really spoke more to the trivium in the revival that has come in recent years. And so with that, right, how are we going to move towards something that's more to the true quadrivium? Is that really what we want? I guess that's the question too. There are some people out there, Wittenberg Academy comes to mind, as one of the forerunners, I would say, with a more truly classical program. But I would say for all of us, we need to think about where are we at in the continuum, right? There's kind of this continuum, I would say, between this classical idea of quadrivium, of integration, of less, get to march to calculus, and more toward what would be authentically classical. So that being said, what would a truly classical program look like? I would say they're more to no textbooks, right? Original source text is what we would say would be part of the true classical model, right? Integrated subjects. I know when I was speaking with my husband who grew up in Germany, who attended gymnasium, and I think even the word gymnasium, there's definitely some underpinnings there of classical. He said, and I asked him, I said, well, what kind of math did you have? And he said, well, I had math 1, 2, 3, 4. There wasn't really a separation, right? And so I would say, maybe if we lean more that direction, if we could even create something like that, it would be amazing. And that arithmetic and number relationships were really emphasized. I'm sure he had modern mathematics in that, right? So calculus, algebra, that sort of thing. But that even just understanding, ratios and proportions, right, would be part of a truly classical program. And so again, Wittenberg Academy, I know the quadrivium program. I've not talked with her. I think her name is Rebecca McCurry, and some of you might know her. But I would say that that's probably one of the more truly classical programs that I've seen out there. Likewise, Classical Conversations Math Map is coming out this year. My daughter's still involved with that, and many on our campus have said, hey, Cheryl, can you come and kind of give us your perspective on that? And so I've had a sneak peek. I do have samples of it, but I don't want to undermine CC either. But I have taken some things from looking at that program. And I would say they've had to create their own canon, and it is beautiful the way it has been organized. And so again, I'll try to summarize what I've seen as those things for you. There's another one called Polymath. I've not actually reviewed that one. But again, there's a few coming out there. I did purchase a book, and I only got the teacher edition because the student book was really expensive, but it's just straight up called Quadrivium if you just look that up. And copyright 2023. So, and it's I think from some Catholic press. And so there are definitely things coming out now. So I guess I'm putting out a little, all call to the Lutherans here now, and for those of us here and saying, look, we need to really think about how could we formalize this and how could we do something with this. So I'm excited for that. The neoclassical end of things, obviously textbook driven. And the reality is, and I've been there, we need textbooks, right? We need something that gives good guidance. One of the research points that I remember from being on the board of directors for the local math, community math center, we tried desperately to have like a cohort of local math teachers, and the takeaway that I had from that is that it's really not about the teacher in a lot of cases. If you have great and well-organized systems and courses, it can really greatly improve, obviously, your math curriculum. And teachers, of course, we would all say are super important. But if they're using poor materials, you can't go anywhere with it. So choosing books wisely, obviously, is important. And again, neoclassical, of course, you're going to have separate subjects. I think it's great, and I was speaking with some gentleman, I don't think he's here, but he said, yeah, I teach most of the subjects for the high school. And I was like, oh, that's great, because you can integrate that way. You can have those conversations that are cross kind of curricular. And so if there are ways that you can think about that, that's definitely a thing. I've personally had a difficult time myself with the march toward calculus. I think the march toward calculus undermines a love of math in a lot of cases, and I feel like the ancients really honored ratios and proportions. They honored basic math. And I know Alex Bianco just from CCLE recently had something on teaching that classically, and he said, well, hey, wouldn't it be great if we could just really ponder simple things that really are beautiful? And I know there's tension there, having been an administrator, having certain criteria, having parents, right? There's the tension there. So it's worth a discussion, and I'm just going to encourage you, if there's maybe one takeaway or one thing that you can take from this, that would be a way to maybe go in the right direction toward something that's maybe more restful and something that's more classical. And classical schools that I've seen, they typically use, or pseudo-classical, typically use like a Saxon, Singapore, or Harold Jacobs text. Those are traditional ones. I think there's Forster in there for high school. And I can speak to that. I've had numerous people when they're like, hey, what are you talking about? And I say, oh, it's math, and, and Saxon, and, some various things. There's good and bad. I guess I would say Saxon is great for building the grammar stage of things. I don't think it breeds good conversation. So if you use Saxon in your school, you will have to dig deep and find some conversation pieces so that you can build in more of the rhetoric pieces there. So I personally, and I know also too, we want to instill a love of learning with our students. And so how do you do that? And so I guess before I move on to other things, I don't want to say that Saxon isn't good, but I do feel like, maybe take pieces of it and not take the whole and digest the whole, because it's overwhelming, and I've seen too many students that have shut down with it, and too many teachers that have kind of gotten burned out by it. So you might be a lover of that, and that's great, but I would say try to supplement and see if you can bring in some other pieces for students that maybe struggle with that. So think about where you're at in the continuum. That would be my thing and my challenge to all of you. And what would be some strategies? What would be textbooks to consider? What would be some support that we can think about? I think a lot of it lies in looking at the Trivium and how we can use these things to strengthen our math programs. And again, all these experiences I've had in life, they all kind of pointed to that ultimately. And so the idea of memory, there's been several already given in some of the presentations so far this week. I know there was a great one on catechism. That was great. In fact, if you haven't read, is it the Matt Bianco book, I believe, which is the Something They Will Not Forget, I think?
Yes.
I hope I'm putting it correctly. Yeah.
Josh Gibbs.
Oh, Josh Gibbs, yeah, sorry. The other guy, yeah, sorry. Sorry, Josh. But yeah, great book. And it even talks about tithing your class time. I thought, wow, what a great way to think of it. Tithing your class time and sacrificing that 10% of your class time to have a catechism. And I loved the presentation. I know we'll all have a chance. If you can watch the catechism presentation, I would highly recommend that, because And I believe it was one of the deaconesses, Allman, I think Deaconess Allman, I'm sorry, I don't know everybody, but she did a great job of kind of giving here's how you form a catechism to help students remember things. My 16-year-old, God bless her, homeschooler, Classical Conversations homeschooler, she will resist, because there's one, but she'll have to do it this year, little does she know. And so I'm excited to kind of implement this. She's my guinea pig, poor thing, yeah. But I've learned the importance, especially in algebra. There are things, and there's beautiful things that our students have to just know it like that. And not just to give the dry recitations, but to give inspiring things. There are beautiful mathematical quotes. I did get a book. I did not put it in my list in case you get the presentation from me and write me a note. But it's called like Math Devotional or something like that. And it has beautiful artwork and quotes by famous mathematicians. Now, I cannot, disclaimer, I'm not sure if it has a Christian undertone necessarily, so you might have to dig deep on that. But it's really a beautiful book for the artwork, if nothing else. So it's very inspiring that way. And then, of course, we have the songs and chants, and those are pretty common. I didn't realize, for example, that Matthew C. actually has a CD of math songs. And I would even challenge you to challenge your students to come up with their own song as a class, or maybe divide it up and, I don't know, different fact numbers, and then teach, having students teach their song to the rest of the class. Let them own it a little bit. But songs and chants, especially I would say chants for the older students, they're not going to be in the song as much, but even just the rhythm of it, that's how I was taught by math facts. And so obviously solidify those things, that's super important. I have participated with math circles, which is kind of a more modern sort of approach, again, through this math center. And I kind of have to cringe a little when the director for the center is talking about, well, we want to have these kids talking about math. But guess what? They don't know their math facts. And so, if somebody puts up some pattern or somebody puts up 2, 7, and 14, if they don't know their math facts, they're just going to feel they'll have nothing to talk about, right? So as much as we would like to say, well, they don't really need to know, no, it could be complete fluency. I truly believe that. And if you have an issue with math facts in your classroom, I will admit that there are ways you can do it with flashcards and all the different, I can't remember what, with the wrap-ups or whatever, yeah. I'm secondary, can you tell? Yeah, so that's the wrap-ups, yeah. That day, right? There sometimes I think is a time and a place for using a computer. And so I do believe that there are some very smart programs that, and I don't know what they're called, but they do help kids learn their math facts. And I do feel like that would be a place where you would say, you know what? My kid spends 18 seconds dancing in between the math facts, right? It takes too long, and it still is too painful. And so I would really encourage you to make those as automatic as you can. Either, and I think you can get classroom things of that if your kids have computer time, or, and even for your kids at home, I think that's a great thing. There's also catechisms you can get online. So again, feel free to write me. I apologize. My email's up there. I wrote classical solutions above that. I actually have business cards, but I'm really shy about just giving those out. But the email I have on my business cards is different. This is a better way to reach me, actually. But and it's not really a business, but more like a encouragement sort of thing. But the catechisms, you can find those online, and so I would definitely look for those if you just want some more ideas on that.
So just to,
Yeah.
like, I can Google math catechism.
That's a good question. So I know that in listening, well, I can give you the names of some of the schools where they have catechisms, and so, and I can give you the name. There's an algebra catechism. It's called the Antiquities Algebra Catechism from Liberty Classical Academy, and that's a good example. Likewise, a math litany. I thought that was interesting. By Sarah Rule. That's what I have here. And geometry catechism. Yeah, you might be able to specifically get that. By Greg Wilbur from New College Franklin. An example of some catechism questions.
That's what I want,
Yeah.
definitely.
Sure, yeah. Here would be, so geometry catechism example would be why do we study geometry? And the response would be, we study geometry because God has revealed himself in the things that he has made. All creation sings his praises. And number is the language of creation. And what a beautiful thing to recite in your mind and remind yourself every day. Yeah. Another one, and again, some of these, you might have to change the words on some of these because they're not necessarily Lutheran people, but it sounds pretty good. Who are you? I'm a vice regent of the Creator entrusted to rule, tend, cultivate the cosmos as a sub-creator to bring harmony to discord and to be an agent of peace. That was really interesting. But again, and I think Deaconess Allman does speak to kind of more specifics. Here are things that you really need to think about including. And so you can see the piece of, why are we doing what we're doing? And who are you and how do you fit into this? And so I think that those are things that you want to include in those catechisms. And then here's another one that is really profound, right? Is mathematics created? Mathematics is discovered, not created. And I thought that was another really good one because I think, I think when we put our kids to, okay, you're going to create something here and dabble in some of that instead of saying, okay, here, it's already been discovered, we're rediscovering it. I think it puts a different spin on things. And then, of course, you can go into the more specific geometry things, right? What is a point? A point is that which has no part and represents the monad. That was actually an interesting word that I learned in doing this, which is the most basic or original substance, more philosophical. So you can make it as plain and simple or difficult as you want. I do know that Deaconess Allman had mentioned, leave it to where maybe not everything in your catechism is well defined, so that as they're learning, then some of those things light up, and as they're reciting it every class period when they come in, then the light bulbs will turn on and they can own that. So again, I would definitely review her presentation on that. She gives a lot of good specifics and again, encouragement for the memory work. Likewise for inquiry, I found this was really interesting. I'm kind of a junkie on cognitive psych. I like to read all these things. There was some discussion about intelligence, and so I always, my lights up with that. And what they're now saying is, you probably caught when they throw out IQ and then it becomes EQ, right? And there's all these other things, right? Ultimately, right, it comes down to asking intelligent questions, right? It really does. Intelligence is a right, asking questions is a form of intelligence. And so I do believe as math teachers to their math students, right, we should be encouraging them to ask good questions. And so that being said, I don't want to ask a question about something that's completely dull, right? And so with good questions comes good, with good materials, right, and good good problems, right, scenarios, comes good questions. And if I had to give you one task for the year, right, it would be find some comrades that you can sit down, and it might be a 5 or 10 minute thing that you do every day, but somebody that you can team with that can help you formulate the questions, because those are difficult. And I was trying to, with my formulate brain, think of, okay, what would be the way I could make it more like a formula, like a plug and chug to make it easy for you guys. This is how you find a good question.
Maybe 5 topics.
Yeah, 5 common topics is definitely, and I was going to actually kind of get to that. So 5 common topics is a great way to generate questions. But I was actually thinking about how do you find the scenario that will generate the most questions. And so my one original thought, and maybe you guys have some ideas too, is make the question slightly ambiguous, right? Like take out something or add in something or throw the curveball in there. That's just my gut feel, but you might want to dig deep with your colleagues on that and find that. I read Mathematician's Lament. I don't know who's read that in here. It's interesting to read that, and he makes the case, for example, right? If I'm teaching that the area of a triangle is half of a rectangle, right? I mean, I can just say it like that, right? It cuts down on time, it's a lot, easier, whatever. But he says, why don't you just play with it and ask your students, what fraction, right, of the rectangle is the triangle? Now, the way I drew it, maybe it's easier to see, I don't know, right? You could draw it all different ways, and that would even be new, right? Just making something a little bit to where it's a guessing game. And he even, oh yeah, go ahead.
Well, it could be the little triangle, it could be 25%.
Which
Yeah, which triangle, define.
Oh yeah,
define which
true,
triangle.
and that's true, I was thinking of this one here, sorry. But yeah, you would, and see, that's the whole thing, and so there's ambiguous terms there, right? We don't know exactly what's being talked about. And so, yeah, he says instead of just spilling the beans on the formula, find a different approach on that. And so again, that's another discussion, maybe a presentation for another year, that we just go through and how do we really, find ways to ask those questions. And so, yeah, you have to have engaging scenarios. A really great genre of problems is Fermi questions. So Fermi, I don't know his full bio, somebody out there probably knows it, but I think he was a scientist back in relationship to the nuclear discovery of nuclear energy back in like the 1940s. And somehow he also had a genre of problems that I would highly recommend, which are just super fun, right? And there are problems like, how many marshmallows would it take to fill this room? That's kind of, now, it's completely not practical, but let's face it, classical is not always practical, right? But then you have to define marshmallow. You have to measure the marshmallow. Then you're talking about volume. It's limitless in terms of the sorts of questions and answers and conversation that you can have. And it pushes students to think about real things and things that true mathematicians, I think, really need to consider. And so you can definitely generate questions online, by Googling Fermi questions.
Please spell that.
We just Googled it.
Oh, Fermi? Yeah, FTRMI, I believe. Yeah. So Fermi questions are really fun. And just, it's one of those things where I don't know about you guys, but at the end of my lesson plans, I always have the if time, like if I actually have the time, and here's some other fun things to think about. And so, yeah, Fermi just, and then what's great about this, and I'll talk about it more with the rhetoric piece, but then you can have them write about it, right? Which becomes a whole other thing, and then comparing and, hey, class, who thinks that this might be the better estimate and why? Let's talk about that. And is that really true and why? And so, yeah, because it becomes an interesting thing there. So let students struggle with things, don't always spill things. I mean, we probably know that. 5 common topic questions are really great. And if you're not familiar with that, I believe they kind of stem from Lost Tools of Writing. Am I getting this right? Yeah, something like that. And this is something that Andrew Kern is, I know, really big with in his writing program. But the 5 common topics are wonderful for generating all of those things. Just a time check here. Yeah, it's 11:30, I think. Yeah. And so what are those, right? Definition. And just like you would have in debate or in a trial, right, you have to define your terms, right? You have to make sure that you're all on the same page. So definition, what is something? What is it not? Those are big questions. And I do actually remember from teacher training when they said, when you're talking about triangles, draw triangles and draw non-triangles and then have your students, see which is which. So definition is really important, and you can have your students ask questions, well, what is that? And what does that mean? And what are all, basically you can have any scenario, any of the nouns in the scenario, what is that? There will be words they will not know. I know I did an inner city cooking math class. Boy, was that interesting. And yeah, a lot of work, but it was great fun. And I printed out the recipes, just online recipes, handed it to the kids, gave them a highlighter, and I said, highlight all the words you don't know. Wow, was that interesting? Because there was a lot of things they didn't know. But again, it was the start of a conversation, and it helped me figure out, what definitions do we need to take care of here? So, and without them having to ask all the questions, that worked out really, really well. So definition is a huge thing in terms of figuring out what something is. I'm going to put a star by the next one. Because honestly, if I'm working with a student in a textbook, or if I'm tutoring somebody, I have found that comparison is one of the best tools. How is this problem similar to that problem? Which answer, right, is more eloquent than that answer? Like comparing things constantly. And so I would definitely say that this is a powerful tool. The idea of comparison is, I believe, and I hope I have this all right here, what comes before and what comes after. I think, am I doing this right here? For those of you who are. and so, yeah, what came before, what comes after. In the same way, what's the relationship between two things, right?
That's the what comes before.
Is that the what? So I was thinking, I'm like, I don't think that's right. Why am I blanking on comparison? Somebody else?
It's the next step.
It's, yeah.
It's logical.
Yeah, right. And so, right. And I'm trying to think of the other. Let me make sure I have the 5 here. Relationship, testimony or authority. And in a math class, I would say rules, right? What rules apply in this situation? That'd be a great question, right? Or what does Euclid say about this? Right? That would be an authority sort of question here. What am I missing on circumstance? Sorry for my handwriting here. For circumstance, it would be, is this answer applicable given the situation that we're in? Or does it make sense even? That would be a way to think about that. Again, this is something, I believe, that you should be able to look up online, but I have samples and things too. I didn't bring all my resources with me, but I do have them at my car if anybody wants to see any of those. But yeah, circumstance is another thing too, right? When do we use the fractional answer and when do we use the decimal answer? That's another one. Are we in science class or are we in math class or are we in cooking class?
And what difference does temperature make?
Right, exactly, yeah. There's so many different circumstances or context that we need to consider here. So, yeah, this is a great way to generate some questions. Yeah, and then creating a controversy in class, I think, is always a great thing. So my mantra as I was teaching, the challenge for me was always, can I create some sort of controversy in class? So again, I think if you take out some facts, or if you present, the marshmallow problem, you might be able to generate that. But I think that's something that's fun to think about with your colleagues. How could I do that to help my students become better in their question asking and even in their rhetoric, right? So it kind of pushes us to the next point. Just make sure. Well, and let me give a list of some example resources here. And this is actually another one of my goals, and again, it might be at the beginning of a conversation, but that is in terms of excellent resources. So if we say that we're, kind of neoclassical, more textbook oriented, right? Wouldn't it be great if we had a list of resources that we could all be looking at that would make for great, supplementary material, basically. And so that's one of my goals. I do have some lists started already. I even have teacher resources, which is lovely. I found that in some of the websites, and I just haven't had time to scan and put it all together. But I would really like to do that because I know myself in a classroom situation would really appreciate something like that. So if you're interested, write me a note, and I'll let you know when I get it, and then I can send something back to you. But a few that come to mind, like math mysteries, any sort of mystery, I think is always great. There's one called Math Mysteries, grades 3 to 5, so for elementary, by Jack Silbert. I have not reviewed that book. I don't actually own that book. I know I own several of the Math Mania. It's just a series by highlights, but they have some really fun little scenarios in there again, that give opportunity for the inquiry and asking the questions and then, oh yeah, what should so-and-so do next? And again, some of the logic that's in with that. The history of counting, right? Giving some of the history and the background, of course. When you know the background of something, it just empowers you to be able to ask more questions about, well, how did it get to this point? Or, why is the proof like this? Or that sort of thing. So, and again, it kind of sparks the idea of wonder, right? So, at the secondary level, again, just a few, this is just the tip of the iceberg, really. Mathematics for human flourishing is one that my daughter did this last year. It was something that her director had them read, and it just lit her up. It's Frances Sue is the last name, and it just had a really interesting, lovely perspective on how we flourish as humans, right? When we acknowledge so many beautiful things in math. Another one that I enjoy looking at and using myself is Mathematics, a Human Endeavor. It's another Harold Jacobs text. It was one that they used at the university level for the non-math majors, and I'm like, what a lovely book. It's just such a great book, and if you've ever reviewed any of the Harold Jacobs texts, he has just a lovely way of giving a lot of context and a lot of interesting applications and scenarios that kind of make it easier to want to ask questions and dig deep on that. The Mathematical Universe, another one, William Dunham, I do own that one. Agnesi to Zeno, over 100 vignettes from the history of math. That's another one. I like that one in particular because they're just short little snippets, and they give some good applications on how you can supplement things.
Can you say that one again?
Sure, it's called Agnesi to Zeno.
Can you spell that?
Sure.
The first word.
Agnesi. Agnesi to Zeno. Zeno. You can look at that one because I have that one too, yeah. And again, just to pull some things in and give a historical context to some of the things. Another thing that I ran across along the way was something called essential questions. And so back when I was in the public schools, they were sending me to New York City, and oh yeah, he's going to do this amazing cutting edge work. And one of the main things that we examined is the idea of essential questions, which is another interesting. You can Google that, and you will find lists of those. But the way that I would characterize it is questions that can't really 100% be answered, but they kind of cause your students to want to ask more questions. And so, an example for at the elementary level. And again, maybe you could say there's a final answer, but it might give some room for discussion and thought. How are patterns useful in the real world? Right? Can you ever, there's always going to be something else that you can add to that list, right? So that would even just be a fun question that you just work on answering all year long, right? How are patterns helpful? And as you see patterns come up, you just keep adding to the list. Here's another place we saw patterns, right? Or here's ratios, right? Here's another place we saw ratios. But yeah, can you ever really fully answer that? Here's another one. Why are opposites so important in math? As you continue to grow as a student, or even as a teacher, you see more and more reasons like, oh yeah, it's really important that I had that option of I needed an opposite here. Or even inverse operations, that comes to my mind. I think that's foundational for algebra. You just have to know an inverse. You have to understand that relationship if you don't have that. And so that would be, why are inverses so important? And then it's foundational for the whole entire year in your algebra class, right? Here's another great one at the secondary level. How do people use data to influence others? I personally think in this day and age, and I couldn't remember the book, maybe you guys can help me out here, but I know that there are books out there that we need to use with our students that help them see the manipulation of numbers. And again, that would be part of the rhetoric, right? I'll speak to that more in a moment, but that's the rhetorical piece, is how can you use numbers to motivate people, right? In the same way, how do you keep from being motivated by others with numbers? So that's really important. So those are just some essential questions, but again, you could just always have the idea of questions in your classroom. Okay, so rhetoric. How do we do that? You could say it's really easy, I'm just gonna, I'll have them write a little paper about so-and-so or such and such, right? But I think it's a little bit deeper than that. And so one of the things I realized as I was doing some of this preliminary, let's just call it analysis of what Lee Hortz has done with her math map, I believe, so if we think of rhetoric and the 5 canons of rhetoric, right? Part of that is an invention. And so I would like to put it out there that I really think that when our students see amazing forms of things, that it just makes things crystal clear. So what do I mean by forms, right? Forms might be, how do you, in fact, I wanted to think deeply about how I had this up here. Students need to be taught how to organize information and how to tell the full story in the way that they organize things. And I think what I love about the math map design is that they have things so well organized that you begin to see all these patterns and things you've never ever dreamt about before.
Can you just
And so-
define math map for those of us that might not catch that title? Like, what is math map?
Yeah, so Math Map is the Classical Conversations new math program that's rolling out this year. And Lee Borns has spent 8 or more years contemplating, and she has an engineering background herself, but she wants to solidify a canon, so it's one that they've invented. So basically a way to organize, truly classical math in a way that's going to make sense. And that can be executed K-12 simultaneously, which is amazing. So, wow. And I mean, it blows your mind looking at it. It's just beautiful how she's organized it. So I commend her for that. But my main takeaway from that really is, and it doesn't really fit in here, but it does. It fits in a little bit with restful teaching, and that is giving our students time to just look and to look at the details. And one of the things that we do in classical conversations a lot is we say, what do you see? Which kind of parallels what we would say, what does that mean, right? But it's what do you see? And as teachers, there's always the rush, getting through, time is it, and that sort of thing. Am I going to make it through? And that's where the less is more is really important, because we have to let them dig deep. And so what do you see is great when you're starting out with an unfamiliar problem. What do you see? Just tell me, what do you see? And I could have done that with the rectangle triangle problem, right? I could have just said, what are you going to see up here? And then when you step aside and you let them talk, right, then they're already getting themselves kind of emotionally hooked in it a little bit, right? Of course, that wasn't super inspiring. You might find a broader problem than that, but right? But it generates a lot of good thinking. And so she has that built into the program. You have to see and look, and you have to look at the details, and you have to look at these charts, and you have to start to own it and put it up here, and then you refer back to it and you look back, right? And it's really beautiful. But then what I love is when the students are filling out their work, the progression of how they have it organized, I think, is really strategic. And so, again, less is more, pure, really well designed problems. Talk about those with your colleagues. That would be maybe, something to think about for this year. So again, comparison is a really important thing to think about as you're generating conversation and you're thinking about writing, presenting. One of my favorite, and it's not really comparison, I guess maybe that's a bad word here, but in thinking about rhetoric, right? It would be dreams, wouldn't it, to have a whole classroom filled with dry erase boards and to have your students come in, and I'm thinking more high school level at this point, but even with elementary and even your students at home, right? Write out problem number such and such, and every student has a different problem, right? And then you can have them ask questions of each other, like, oh, I didn't get that on number 14. Why did you do it like that? That doesn't quite make sense, right? It'd be a great way to check the homework, right? It'd be a spot check of the homework. you could just say they presented on number 14 and that just is a whole nother level of, you gave them a quiz, right? Now, I don't know how well that would go over with students feeling intimidated and all of that, but I had heard that idea and I thought, wow, that's really cool. So yeah, dry erase boards, or maybe everybody with their own little dry erase board. If they're not huge, long algebra problems, maybe that's possible. But yeah, I think that that's definitely something there where they can compare, and depending on your class size, you can definitely have some discussions from that. So again, that would be kind of part of the presenting part of the rhetoric, right? How can we encourage them to discuss things with each other? Any questions so far? Sorry, I'm just kind of talking at you. I'm going to gather my thoughts here as we're closing up here. Yeah, go ahead.
What do you think about problems that start with the answer and then the kids have to make the problems themselves?
Oh,
What do you think about that?
I think that's a great idea. I mean, working backwards is a thing, right? In a way, that's kind of really what that is. And making that scenario, anything you can do like that to help your students own it, I think is really exciting. And then, of course, if you have, like a certain boundary for them, they can challenge each other with those questions, right? It'd be fun to see, like, if you have one answer that everybody has to use, working your way backwards, especially, wow, in algebra, that could be amazing. You come up with some really fun things with that. So, yeah, anything like that you can help your students own what they're doing, I think is really, and then comparing that would be a great comparison of, wow, and not in terms of like, well, this is better than that, but in terms of simply the logic of it or the complexity of it would be interesting to look at. So again, it depends on your audience on that, but I know I used to have my students do problem of the week, which I don't know if anybody's familiar with that, but they're really great problems where students have to dig deep. Are you familiar with that?
No, I was gonna go on what he just said.
Oh, okay, yeah, go ahead, yeah, I would
Well,
love to.
couldn't that technique be used even at the arithmetic stage?
Oh, yeah, certainly at
And all
any
the way up.
stage. Oh, for sure. I think it would just be wildly fun, really. You'd have some interesting things for sure.
I have a different question. You talked about the march towards calculus.
Yeah.
What is your take on, if someone does Algebra 1 and really does not do well, and, we would say if they have to repeat it, that's a negative in everybody's mind, but
Yeah.
thinking classically, the approach would be, we've done it once, let's do it again.
Yeah.
What is your perspective on that?
Yeah, thank you for bringing that up, because I that's a whole nother conversation that needs to be really hashed out. And then we have the math table at lunch today, because maybe we can dig a little deeper on that, I don't know. Yeah, I know in the one presentation that I listened to about teaching math classically, he was kind of idealistic in terms of, oh, well, if they only get to ratios and proportions, even in high school, that's going to be fine. Well, I don't know. I know my daughter, who's, she's still working through the Harold Jacobs algebra. She's going to be a junior, but it's been a transformation for me in teaching that, because I've started it differently, and then now she's owning it and doing it differently and progressing in her own way. And I said, well, you're learning this totally different than the rest. It's okay. And she's like, don't feel like it's okay. Yeah, there's the reality of that. I like the one person who spoke, and I apologize, it's been an amazing week, but my mind is so overfilled at the moment. But he was talking about, different levels. I guess it was the one on creating a high school. That's what it was. And some of the thinking on that. And I liked how he said, all levels of students are in the same room. And in the same way with algebra, maybe it's, realistically, that you would have the honor students with the regular students, but they just have different homework assignments. I mean, that's just literally how it would have to be. For you, you're talking about repeating it. Okay, you have, I know, the option of homeschool. I don't see anything wrong with that. I think it can definitely breed some confidence. It depends on the textbook that you're using. I think if you're using Saxon, I don't think that's going to go well. I would say move to the next level up. I have heard of some people that even just skip, but in the case of repeating that sort of text, I'm not sure it would be helpful. I don't know if that really answers your question, but
Well, and it's more the philosophical idea that if we have to repeat a grade, that's a failure.
it's a failure.
Whereas, obviously, we all learn at different rates, and if you have to do something twice,
Right.
that's actually, on some level, commendable, unless
Sure.
unless you failed because you were being lazy.
Yeah, yeah. Yeah, go ahead.
So I also saw the Classical Conversations math map
Okay.
presentation.
Yeah, yeah.
Can you talk a little bit about part of that formulation
Yeah.
is teaching everything throughout the year,
Yeah.
even at those upper levels.
Yeah.
And then it's early exposure and they'll differentiate,
Yeah.
but be in the same room.
Yeah, and that's exactly, it kind of hits on what the one gentleman was saying, and second time around, and obviously with math, they're starting at kindergarten, and they're there with the high schoolers, and they're looking at the 7th grade program. I mean, they get to calculus, so they're doing basic calculus, foundational sort of things. Yeah, I think the idea of repeating is a lovely classical piece on that, and the way in which you do it, I think, obviously has to be hashed out a little bit more, and it's situational, but yeah, I think, yeah, there's some lovely things, and introducing students, they're not gonna get it, right? They're not all gonna get it, and even, and I think it's honestly an esteem thing for those students that are, at a lower level, more remedial, that they can be in the same class with those other students and that they're hearing it. And so, and then the repetition, of course, is really a beautiful thing. So I think these are lovely themes. I feel bad, I feel like I'm teasing you all with just these ideas, but I think it means that, there needs to be more conversation on this, and I would love to see, Rebecca McCreary and different people, kind of spearhead a movement toward, hey, how can we really develop this into something more? Obviously, the Boards is onto something with her program, but that's not realistic for, school implementation sort of thing. But I think it would be a great way to work together and to help really, truly undergird true classical mathematics.
So without doing the march toward calculus.
Yeah. Oh, wow, I sort of praise you.
Is there a program that would prepare that student who's going to be an engineer more effectively than another?
Ooh, that's a good question. I mean, I like the Forester a lot. So the progression of, I think even the Jacobs algebra works really well, but then there's Forester, and then beyond that, there's certainly, I think there's a calculus, a Saxon calculus book, if I'm not mistaken. Is there? Yeah. I don't know. Again, I can't say I've actually ever reviewed that, but I know the Forester, what I loved about it is that it's very problem-solving oriented, and I think at that level they should be at a more rhetorical level. I mean, of course they'll have their basics, but that's your algebra, and so by the time you get to calculus, you should be able to discuss things a little bit more. So.
Math is likely, since it was developed by an engineer, and
That, yes, and that is, and she did actually say, because it's very reading oriented, which I think is lovely. So one of the basic premises of her program is, look, I want everybody to know the symbolism and know the terminology, so that when they're reading, in college or wherever in life, that they are well equipped. And I know, looking at the first lesson, I never realized the fourth dimension of what it was called. So it's latitude, longitude, altitude, vicissitude. I didn't know that. And I'm like, where have I been? Apparently I have not been through this program, I guess. So yeah, I mean, there's just a lot of lovely, terminology and symbolism, and, and helping those kids just be so confident and now, and being resourceful. I think that's another thing, is helping them to be lifelong learners, that they want to dig deep on some of these, information pages and things like that. So yeah.
Did you see some examples?
I do have some samples. Unfortunately, they're in my car. I realized the cart that I had them in was broken, so I was like, I'm not going to drag it around and it's broken. But yeah, I'm going to be at Ruth, and so if you catch me today, maybe in between, we can
I'll
look at
follow
that.
you in the back.
Okay, yeah, that's right. You and I are both dorming over there.
Are you gonna have them at lunch? Is that what you said?
I won't have them at lunch, but maybe shortly after lunch,
Okay.
what time we get out. Yeah, we could dig deep in the back seat. So, any other questions that you guys have? You've been a great audience. Thank you so much for your listening, and I'm humbled by you all being here. So, thank you.